Friends, how are you? Do you know about the cool fact about the Eiffel Tower? The main material is not steel, but in its modern sense, it is puddled or welded iron. Puddling? It is an obsolete method of processing hot metal into soft, low carbon iron without contact with fuel. At the exit of the furnace, the molten metal was processed by flatting. This material features decent weldability, high ductility, and low impurities. So, let's learn about these steel structures. In today's video, the contract document and detailing process part 3, we will see about the types of columns in steel structures and see the column schedule. We will also see the drawing in which there is stepped column. In the previous videos of contract document and detailing processes part 1 and part 2, we have seen the types of contracts like lump sum contract, unit price contract, and also saw the operating data sheet. Please watch those videos. The link for those videos is provided in the description box below. So let's start today's video. Contract documents and detailing process part 3 from the manual Detailing for Steel Construction 3rd edition chapter 2 page number 2.7 and 2.8. Today's topics: design information, engineering design data, types of columns, and column schedules. This is A752 from the appendix. The design drawing of an industrial building that must support an overhead traveling crane having a lifting capacity of 15 tons. In this building, columns are subjected to large bending force because in addition to the bending moments induced by wind, the operations of the crane will also impose horizontal forces at the crane girder level, which must be registered by a column in bending. In this structure, the engineer had given special attention to the problem of developing suitable connections for the stepped column, where upper shaft is spliced with the lower shaft and where lower shaft is fastened to the foundation. These connections form a very important part of the structure. Engineering design data. The information needed for detailing columns as well as other structural members is normally found on the structural design drawings. These drawings show the size and location of all the parts of the structural frame using plan views, elevations, sectional views, enlarged details, tabulations, and notes. They should include all information necessary for complete detailing. Plan views. Locations of column centers and indicate the orientation of column faces. This is the foundation plan. This is first floor plan, second floor and third floor. These are the details shown. Beams and girders shown on column centers are assumed to connect at the center of the column wave or flange. Because the structural design drawings generally are small scale line diagrams, enlarged sections are sometimes employed to locate off-center beams and to clarify special framing conditions. This is true particularly for perimeter or spandrel framing, beams around stairwells and ramps, and members at elevator openings. Enlarged parts of the design drawings, such as those adjacent to corner columns, may be used to indicate the designer's solution or to alert the steel detailer to complex situations. Beam connections to columns may be designed to resist wind or seismic forces in addition to vertical floor loads. Such special connections are sometimes sketched and tabulated on the design drawings and keyed to the beams by numbers and symbols. Ordinary frame or seated connections are usually designated by note or specification reference, as are the bolts or welds to be used. When vertical bracing, trusses, or built-up girders are required, the necessary views are shown in vertical sections or exterior elevations. Types of columns. Most frequently used 10-inch, 12-inch, and 14-inch W shapes. Even though design conditions sometimes require sections built up of several components, designers utilize W shapes as rolled whenever practical. Special I and H-shaped columns and box sections, sometimes with interior waves, can be made by welding plates together. So these are the types of columns. This is W with plates. These are three W shapes in one column. Three plates are welded together to form a column. This is a box column, box width wave, and cruciform that is in the shape of cross. Double or triple shaft columns, lace or batten are connected with diaphragm may be used in mill buildings where crane runways and roof supports are combined in one member. These are the columns for light construction. Tubular columns of round, square, or rectangular shape are used in light structures and for architectural reasons, often supplant W sections in schools and small commercial buildings. Are identified and oriented on the design drawings by an appropriate symbol, usually the column shape in cross section, and are located by a system of numbering. Their location may be established using either a simple numerical sequence as 1, 2, 3 or two-way grid system with column center lines assign letters in one direction and numbers in other direction. Thus, a column at the intersection of D and 4 would be D4 column. Column schedules. It shows the information on the size and length of columns required in a tier building. The column schedules sometimes contains member loads which should be included when required for the selection of the column splice connections. The schedule shows column size here and specifies the elevation at which the size must change. For reasons of economy, fabrication, and handling, splices usually occur at every second or sometimes every fourth level. Thus, each individual column length supports two or four floors, termed a tier. Horizontal reference line column schedule represents finished floor lines or some other reference plane. Elevations of floor framing as well as column splices are referred by note or dimension to these lines. Bottoms of columns or tops of base plates and the cutoff points at the column tops are located similarly. Conditions do exist when it is proper to provide a column splice after the first level, and direction logic of a project should be considered when choosing column splice locations. Locations of column splices. Because the lower tier is normally heavier, the column splice level is kept as low as possible in order to reduce weight of materials. Splices must be made at least 4 feet above finished floor level on perimeter columns, as required by OSHA 1926 Subpart R to permit the installation of safety cables. The elevation of the splice must provide sufficient space to allow for the splice plate and beam connection to be made without interfering with each other. If the structure is braced, sufficient space for the bracing connection should be provided. The splice elevation should accommodate the erector, who will make the connection. To splice a column at mid-height or point of contraflexure, that is, a change in the direction of bending moment in any member, can require additional expense because scaffolding can be required for access. This is troublesome, particularly during erection of next tier. Summary: we have seen an industrial building drawing with stepped column, engineering design data, and types of columns in steel structures and their schedule. For the content in the video, all credits are given to the AISC committee who prepared the manual detailing for steel construction. I am grateful to them. Thank you so much. Thank you so much to you all for being with me throughout this video. I am grateful for your support. If you find this video useful, then please share. It will help others. And subscribe to get notified about the new videos.